Well, hello everybody. This is SQL Dan, and today I'm here to talk about counting of nulls. It's an issue that comes up fairly frequently, especially when you're doing things like data quality testing, and there are a number of different approaches, and I'm going to talk about a couple of those. Now, first up, I'd like to acknowledge that I'm aware that Snowflake does have a null count function. The problem is that it's only available for people who are on the Enterprise Edition, and so if you're not, you're kind of out of luck unless you have another approach, and so that's what we're going to talk about here. Also, the data set that we're going to be using came from Kaggle. It's called the Retail Transactional Dataset, and it was prepared by Bhavik Jikadara. So if you'd like to work along with me, I encourage you to download the dataset as well. I will put a link to it in the description of this video so that you can find it nice and easily. Okay, so back to our dataset here, or back to our table, I should say. So I've loaded the data from Kaggle into a table that I just call retail data, and a quick query of it will show us that there are 30 fields and a whole lot of rows. But what I'd like to find out is if there's any nulls in here. And, I might be able to figure it out by scrolling up and down. I might miss some. It's hard to say. The thing that I really would like to do is be able to write a query to find out for ourselves. And I'd like to be able to test every single field to look for nulls, not just in the first field, but all the way down the line. And that's what we're going to do today. Okay, so starting with the basics here, the most basic way to get a count of nulls is to reference the field inside of the where clause. So we'll start with the first field here, transaction ID. And you say where transaction ID is null, and we just select the count. And when we do that, I run this query, and I discover that there are 333 records with a null value and transaction ID. Now that doesn't tell me anything about any of the other columns. Maybe they have more, maybe they have less, maybe they have none, maybe they're the same ones. I just don't know. So I really have no choice if I'm using this method but to go through and do them all one at a time. So instead of transaction ID, I can type customer ID, and I can run this one. And this one has 308 nulls in it. If I do name, which was the third field out there, it has 382, and et cetera, et cetera. So you can see that this would be quite clunky if I wanted to do this on every single field. I have to run 30 different queries because I have 30 different columns. I have to find a way to keep track of that. And this is not necessarily a very wide table. If I had a table that had a couple hundred columns in it instead of just 30, this could become quite burdensome. So this is not really the way that I want to attack this. I'd like to be able to write a query that could get me all of those results at the same time. So the way I'm going to do that is I am going to copy this. And right now we're just going to copy it 3 times. Okay, and the first column that we looked at was called transaction ID. Here we go. The next one that we looked at was called customer ID. And then the third one we looked at was called name. And as I mentioned, I'd like to be able to run all of these at the same time instead of individually. So the way to do that is to union these results together. So there's a union all there, and here comes a union all right here. And if I run this, we can see there's my 333, my 308, and my 382. But what's wrong with this approach? Well, first of all, I have no idea which column each of these numbers pertains to. You might make a leap of faith to say that these are in the same order, but you never have a guarantee of that, so you can't be quite certain. So one thing I'm going to need to do if I do it this way is not only do I need to get the counts, but I also need to get the name of the column that was counted, because although it does appear in the where clause, it doesn't appear anywhere in my output. So I need to grab each of these. We'll start with the transaction ID. Control C. And I'm going to add that straight to the query up at the top. And I'm going to enclose it in single quotes as a string. Let's see here. Single quotes as a string. Okay, and I'm going to do the same thing with customer ID. And that's kind of annoying. Okay, and then I'm going to do the same thing here with name. Okay, and so now I have each of the fields referenced here. I'm going to give an alias to the first one just because it'll make the query results a little bit easier to follow here. And again, anytime you have a union query, whatever the field names are on the first query get transported down to all the other ones as well. So I didn't need to add it to all the queries, I could just put it on the first one. But now I have query results that make sense, and I can see field name, transaction ID 333, customer ID 308, and name 382. Now I could go through all of these and do all the rest of these the same way, but you saw how painful it was just to do 3 of these. All that typing and trying to get everything lined up in the right spot. So I'd rather find a way to do this somewhat in an automated fashion and not have to do it like this, because even doing this for 30 of them is going to be a chore. So the answer that I'm going to use is I'm going to turn toward something called the information schema. Now, if you've used the information schema before, then you're probably already aware at just how awesome it is. But if you haven't, stick with me here for a second and I'll show you. Because effectively, the information schema gives you a way to write queries about all of the tables and views and things like that that are in the database. So I'm going to say select star from information schema. Now that's the schema name. So I then still have to provide, I'm going to call it a table name, but I'm aware that it's a view. I have to provide a view or table name for it. So the name I'm going to say here is columns. Okay, and then I need a where clause here. Where table name equals retail, and I have to spell retail correctly. Boy, oh boy, like so. Okay, so let's run this and then I'll talk a little bit more about what we just did. Okay, as I said, I had information schema and then I said dot columns. So this is one of the tables or views that's in the schema. And it's a query of all the columns that are in all the tables and all of the views. So had I not specified a where clause, I would have gotten every column from every table in the database. But I'm really only interested in seeing the columns from this one table that we're working with. So I included that in my where clause. The other thing to be aware of when you work with the information schema is that the names here are strings, so they're case sensitive. So normally we can type a table name or a column name or a view name and have it not be case sensitive, and that's fine. But once we start querying the information schema, it all needs to be uppercase in order to grab it. But what we can see here is it has returned a result set that contains all 30 of the columns that are in my table. Now there's a couple of more improvements that I can make to this. You may notice that these columns did not come out in the order that they are in the table. Like we know, for example, that transaction ID is the first column, customer ID, which I don't see here, so it's going to be further down, is the second one. Email is the fourth one, etc., etc. So we'd like for these columns to be in the same order as they are in the table. And so that's what this ordinal position field does, is it tells us what order the columns are in. So instead of just my where clause here, I'm going to add an order by to the query. And I'm going to order by the ordinal position field. And when I do that, we'll see now that they will come out in the order that the fields actually appear in the table. There we go. Okay, so all of this other information is helpful for at other times. For example, the data type is often very useful, but it's not useful for what I'm doing right now. All I really need is a list of column names. So instead of doing select star, I'm going to say select column name. And we're going to run this one more time. And boom, I've got them all right here. So I could take this whole list right here and I could paste it up to this union query that I already started working on where I had 3 of the fields done. But I would recommend at this point that instead of trying to do that here in the Snowflake web interface, that we pull this query out really quick and we construct it in a text editor and then bring it back here. And the reason for that is the text editors offer us a lot of opportunity to do things in mass that we just can't do here in the web interface, especially like columnar copying. And so what I would recommend that we do right now instead is I'm going to say Control A to select them all, Control C. So I've copied this whole list to my clipboard. And so after I've copied it, then I bring it over into a text editor and I paste it in like so. And there's a list of all 30 of those columns. And as I've said, it's much easier to do these edits over here than it is in the Snowflake interface. And I think you'll see what I'm talking about in just a moment. It's not like this can't be done over in the web interface, but it's just a lot more clunky. Okay, so the first thing that I'm going to want to do is I want to make all of these lowercase. And so I can highlight all of them and I can simply, oops, nope, that's not what I want to do. Maybe it's U actually. So I can highlight all of them and hit Control U and they all go to lowercase. Again, this is not a necessary step, it just makes my code a lot more readable. And now I'm going to select them all and I'm going to do something called column selecting. So you can't see this, but I'm holding down the Alt key at the same time that I'm moving down. And then if I move over like this and hit Control C, okay, and I come back up to the top record, you see there's a whole bunch of cursors there right now, so I'm going to click in to make sure that those don't mess things up. It's going to come out here somewhere, and I'm going to hit Control V and paste it in. And so now you see we have 2 copies of the same list, and without columnar copying, it wouldn't be possible to do this. If you were just to copy the list like this and then try to paste it all into the right, the whole new list would have come in between transaction ID and customer ID. But by having a text editor that can do this, you can save yourself a lot of headache. Anyway, okay, and so now that we have a copy of this, we're ready to start to write our statement. And we're just going to write the same statement that we had before, but we're going to do it en masse right now so that all 30 of them get included at the same time. So I'm going to hold my Shift key and my Alt key down, and I'm going to go right in the front of this right here. Okay, so now you can see I have the cursor positioned on all of those lines at the same time. And I can simply type select count, and I do have to spell count correctly. It's one of those quirks about Snowflake. Of course, I'm being facetious. Okay, and then the name of the table Okay, now white space doesn't necessarily matter in a query, so I'm going to type the is null over here. And it doesn't matter that there's a bunch of white space in there now. I've effectively written 30 queries, and each one of these will select the count from the table where that particular field is null. So the next step is to union all of these together. So I'm again holding the Alt and Shift down to put this in the front of it here. And in front of every single one of these, I'm just going to type union all. Okay, and so now we really do have 30 queries, and all of the results will be unioned together to give us a single result set. And there will be 30 rows in that result set. The problem with this result set at the moment, though, is that we would get the counts for how many are null in each one, but we wouldn't necessarily know which one goes with which one. So we actually have to include in each of these queries which field it was. And again, we know which field is null from the where clause, but that doesn't appear in the output. So we need to get these column names into the select list as well. So again, I'm dropping down, I'm highlighting like we've seen before, and I'm going to put single quote marks around them. Okay, we did it in the front here, and let's do it also here in the back. We just need to be able to go out and put a tick mark as long as the longest value here. It won't matter if there's white space in it or not. So let's try that. Okay, that looks pretty good. So we'll put tick marks right there. All right, and now I'm ready to bring these and put these into the select list as well. You know what, while I was putting these tick marks, I should have put a comma also, because I'm going to need that. Sorry, this is the making sausage aspect of writing a query, right? You go step by step. You don't necessarily have the whole query written as you start out. You put in the pieces as you need them here. So we are now ready to grab this. Okay, and I need to go over here and grab through the tick mark and the comma. Okay, and now I'm going to hit Control X. Okay, and I am going to bring it and I'm going to put it between the select and the count. And remember, it has a comma on the end of it, so it should work well. So I'm going to put it right here. Control V. Beautiful. So now that we've finished that, we're ready to bring that back into Snowflake here. So we'll just paste it right here. Let me scroll up here and let's compare with the query that I wrote earlier. Again, we're selecting the field name and account from the table and then where it's null. So that looks really good, except that I got it all on one line just to keep it more compact. And we should be able to run this query. Oh, one more thing we got to do, and that is we don't need to start off with a union all. We can just start with select, and then we need union all for each one after that. So here we go. Now let's get all 30 of these. And there we go. There are our counts for nulls for each of those columns. So there's number one way to do it. Now I'd like to show you two more ways that are a little bit cleaner and that also can end up with your counts being across in the same order as the fields instead of being pivoted downwards into rows like these are right here. Okay, so one thing that we know about the count function is that count, well, so in this example up here, we were doing count star. What does that mean? Count star means to count records, right? And so it was counting records that met the conditions of the where clause. Okay, but if we put a field name in the count instead of a star, it's going to count only the not null values. So where before, in fact, let's put both in here. Let's put select count with a star. Okay, so that's what we were doing before. And then one more just a count of a particular field. And like I said, the count with the field in it is going to count all of the ones where it's not null. Okay, so there are 302,000 records in here, 3,002.10. Of those, 301,677 have a value in them. So what we can interpret from that is that the difference between these two is represented by the nulls, right? So instead of counting each one separately, what we could do, I'm going to copy both of these right now, Control C. Is we can select the total count of all the records and subtract out the ones that were not null. Just to keep the query clean here, let's see, I need a comma right here. Oh, goodness gracious. I never stake anything on live demonstrations. There we go. So we should be ready to run this query. I'm just going to pull that up there. And here we go. Okay, so here's our count of records. Here's our count of records that weren't null. Notice there's no where clause in here, just a count of records. And then the difference is 333. So we should recognize that number from before as the one with the nulls. And let's just do one more to prove this out, that this can be done this way. And we can say customer ID as so. If I recall correctly, this one was 308. So let's see here. Yep, there we go. So one disadvantage that the prior query had was that it effectively was 30 different queries. Now, I know that I put unions in them to allow us to do one execution, but there was 30 different from clauses. The same table was referenced in each one of them, but those were 30 different times that it had to go and hit that table to make it happen. So one of the advantages of doing the way we're going to see here is that we can do all of these with just one hit against the table instead of 30 or however many columns we have. And as I've mentioned, we don't need these columns. They're not strictly necessary. So let's remove these. So we only have the two that we need for our calculation, which again is the count star and the count field. Okay, and then we can also now eliminate this table name, this from clause right here, and this select right here. And notice we can do this with one pass. Okay, now I'll go ahead and execute that. We're going to have the same problem that we had before, which is, well, I guess we could kind of tell which one goes with which one's here, but this is kind of messy the way it is right here. So what I'd like to do is alias each of these columns in the same way here. So as good, and then same thing here as so we get both of the null counts with just one hit against the table instead of the two that it took to do it the other way. So this way is definitely superior to the way that we did it first of all. We can again go back to the information schema and do this with all 30 of them if we wanted to, but I think you kind of get the idea of how this one works. The third way to attack this is, instead of doing two different counts, is to do a single count for each one. Now this one requires an extra function, but we can harness the logic of the way the count function works and turn it in our favor. Because as I've said, the count function gives you a count of how many records are null. But unfortunately, we want the other way around. So the way to do that is to use the decode function. Now, if you're not familiar with the decode function, it effectively takes one value and then translates it to a different value. So let's stick on track here, and I'll write this out and then I'll explain more what's going on here. So we have select decode from transaction ID. Okay, and if it's null, we are going to put an X, and otherwise we're going to set it to null. So you might be thinking, what the heck is going on there? So effectively what we've done, let's see if we can put it up here. Put the transaction ID. And let me grab the from clause. Good enough. So effectively, we're taking all of these transaction IDs that were not null and converting them into nulls. And then if we find any that did happen to be null, I could add a where clause here to prove this out as well, where transaction ID is null. And let's run this. Now I've specifically picked out ones where it was null. So all the ones where it was previously null now have a value of X in there. So what I've done is I've been able to flip this around, and now the ones that used to have a value are null, and the ones that did not have a value are not null, and then I can count from there. Now if you're not familiar with the decode function, kind of think of it like a case statement. There's two advantages to the decode here. One of them is that a case statement won't match on null. You can't use an equality. We would have to say where transaction ID is null. We can't use an equal sign. But a decode will match on null right here. And the second one is that decode is just oh so compact to make this nice and simple. So now instead of selecting them out individually, let's take a look at what the decode did here. Okay, so we're selecting, and I've nested all of that in a count. Remember, the count does not count nulls. The count counts things that are not nulls. So it counted 333. So effectively, that's my null count for this column. And since we've already done this exercise 2 other times, we know that that's the case, that there are indeed 333 nulls in this field. And we can do the same thing with the next one down. Okay, and this is customer ID. And let's go ahead and add aliases to the end of each of these columns as well to make it nice and user friendly. And I no longer want this where clause here. I just want to get my counts. I lost the from clause. There we go. Alrighty. So when I run this, boom, I now have 333 here and 308 here. And I can use the same trick with the information schema and my text editor and do this for all the fields and get my answers for all 30 fields. So I'm going to cut away real quick, and then I'll bring back the query that has all the fields together in it, and we'll run that. Okay, and we're back. I've got all of those edited, so let's just paste them right here. Let me show you what we've got going on. You should recognize the count, and then nested inside of the count is the decode. And again, the decode is converting the values from each of these fields. If they're null, it's making them not null. And then I probably didn't explain this as well as I should have. The default is null. So in other words, all the ones that didn't get picked up by this first one got converted the other way. I think I'm going to make a video just about decode in the future, because it's actually a super useful function that comes in quite handy. It doesn't do anything that can't be done with a case statement, but it's just so much more compact and makes your code look a lot cleaner. So I'm a big fan of it. And there will be a video coming up on some clever uses of decode down the road. One more note about decode. I know that there's a decode function in Postgres as well. But that has to do more with character settings than with what we're doing here. So don't get this decode. This decode has its origins in Oracle databases. So this is somewhat different than what you'd find in the character set decode from Postgres. So don't get those mixed up. But anyway, here comes the big finale. We are going to be able to count nulls in every single one of these fields. You see we've got them all listed here. I'm only hitting this table one time. I don't have a count star on every single one, which is again extra work for the database. So let's go ahead and run this. And boom, we can see how many nulls are in each of these fields. So that's the lesson I have for you today. Counting nulls is actually pretty easy. It's something that's pretty important to be able to do. So hopefully this video made sense to you. If you have any comments about anything I said, if I didn't get something right, or you'd like to further explain something that maybe I didn't do a good job on, or if you have some questions, I'd be happy to answer your questions as well. Please feel free to comment on the video. Also, I'd love it if you could like the video and subscribe, because I'm creating new Snowflake content all the time, and there's lots more videos like this one to come. Thanks for watching.